Okay, in this Math 2 video, we're going to do 78, 87, and 88 from Chapter 2. So for starters, it says, the side of each pair of triangles below is similar. If the triangles are similar, justify your conclusion by stating similarity condition. So basically, we're looking to see, is it an angle-angle similarity? Is it a side-side-side similarity? Or is it side-angle-side similarity? So if we can prove one of those, then we're good to go. If the triangles are not similar, explain how you know they are not similar. All right, so let's take the first one, for example. I'm going to split this up. Actually, I'm going to color the angles first, so you're not confused on what's going on. This is 90, and then we have this angle here. All right, now for starters, it looks like you have two pairs of angles that are the same, right? The orange and the red, and then only one blue. But it's not trying to trick you. It's trying to make you use your reasoning skills. You technically have two triangles, and I'm going to split them up. I'm going to take the small one out of the big one, okay? And then I'm going to leave the big one just by itself without the markings on this from the small one on it. So this is the small one, right? And this is going to be the large triangle. So we have orange and orange, right? Up in the top corners for both of them. We have the 90-degree angle for both of them, so we're good to go. And it just so happens that the blue one is also the same angle for both of them. So we do have a similarity condition. We have angle-angle similarity, or better yet, just angle. I'm sorry, I was going to say angle, but we just need two angles to prove that they're the same. But now we know why they are. It's because even the third one is also congruent to the other one. So these are, so yes, they are similar, okay, by angle-angle similarity. All right, that's what we needed to prove it. Okay, because we only need two angles, because the third one's going to be automatically the same. All right, part B. Two equilateral triangles. All right, well, if you don't remember about equilateral triangles, right, that just means the sides are all the same. So we're done, technically, right? It doesn't say equal angular triangles, but equilateral means all the sides are the same. So, oh, I'm sorry, this side here is in proportion with that one there. Now, the other thing to remember about equilateral triangles is that all the angles have to be 60 degrees. It just so happens that the only time you ever get equilateral triangle is when all the angles in any equilateral triangle, all three angles have to be 60 degrees. So we do have a similarity condition, and the reason is by angle-angle similarity, because all the angles are 60 degrees. Okay. All right, part C. Okay, so we have to piece these together. So small to large, large to small, whichever way you want to work, but I usually just do the one on the left with the one on the right. So the smallest side here is going to be a 6, and the smallest one here is going to be 15. The largest one on the left is going to be 11, the largest one here is a 33, and then we have the middle one is 8, and then 20. So we're going to put those as a ratio. 6 over 15, let's see, 8 over 20, and 11 over 33. Okay, so for starters, you're looking at this, and I'm thinking to myself, this just looks bizarre, but I'm pretty sure we can simplify it. So 6 over 15 has, what, 3 in common? Anything bigger than a 3? Nope. Okay, so 6 goes into 3 2 times, 15 goes into 3 5 times. Okay, that works out. 8 and 20, they both have a 2 in common. That's true, but they also have a 4 in common. I don't think they have anything bigger than a 4. So 8 goes into 4 goes into 8 2 times, and 4 goes into 20 5 times. So lo and behold, we have 2 of them so far that are the same. Now to the third one, 11 and 33. Let's see, 11 and 33, all I can think of they both have in common is an 11. Oopsie, I should have used green for that one. My bad. Wrong color. 2 out of 5. Okay, wrong color, sorry. There we go. So that'd be a 1, right? 11 goes into 11 1 times. 11 goes into 33 3 times. Okay, well, I don't care if 2 of them are the same. The third one is not. They all have to be the same. So, in conclusion, they're not similar. Done. All right, all 3 of them have to be the same, not just the first 2. And please don't just stop at the first 2. You have to check all 3 because, like in this instance, third one turned out not to be the same. Okay, and then here, we don't know anything about the sides, so that's not very helpful. And we need all angles to be the same. And so far, 2 of them are not, so there's no way that these ones are similar. Okay, it's not 60 is double 30, 50 is double 25. No, that's not how it goes. They all have to be the same. Okay, so they're not similar. 87. The only reason I put this on here is I think most of you kind of know what you're doing, except sometimes you get a little confused. So I put this here for the reason of what is about to happen when you try to solve this. So solve the system that any equations at the right using any method of your choice. You can decide to graph both of them. If you do decide to graph both of them, one line should start at +1 and kind of go down like this, and then the line should start at -2 and then just kind of go down like that. Okay? All right. Algebraically, the fastest way would be to put these two equal to each other and then solve. So 2/5 x plus 1 is equal to -2/5 x minus 2. So this is called the equal values method. Because both of them are equal to y, then you can put both of these equal to themselves. 2 out of 5 is not an ugly fraction, but I'm just going to turn it into a decimal because it just makes me a little happier. Okay. All right, well, I guess I'm going to add 0.4x to both sides because that just makes more sense. There's a 0 pair here. You have 1 equals, there's another 0 pair, 0 minus 2, right? So 1 equals 0 minus 2 is just -2. Okay, this is false completely. All right, technically you have no solution. No x amount that you ever find will ever make those two things equal to each other because they should both look like that. You have what we call parallel lines because the slopes are the same. Right? Both of the slopes of the two lines are the same, which means they will never touch. Right? They are not intersecting lines because the slopes are the same. They are parallel lines, so you have technically no solution to your algebraic way of solving the system. Okay, that's number 87. And then 88 is an interesting problem. Based on the measurements provided for each triangle below, determine whether the measure of x must be more than, so there's an option, less than or equal to 45 degrees. So, let's work this out. I'm going to go with I'm going to go with B first. I don't know. I feel like I want to do B first, and you'll see why in just a second. Okay. Now, when you look at B, automatically it should stand out to you. It's not drawn to scale because obviously this side or the side length here is a little bit less than the side length here, but they are both 18. So that means you have an isosceles triangle. Now, from what you remember on an isosceles triangle, hopefully you remember that the base angles have to be the same. So this angle here, x, has to be the same as that angle there. And if they're both x's, technically, then you can actually set up an equation and figure out what it is. You can set up, that's 90, right? So we have 90 plus x equals 180. We have 90 plus 2x equals 180. Subtract 90 from both sides, you get 2x equals 90. So x divided by 2 on both sides, you get 45. So x has to be equal to 45 here. There's no other option for us because they both have to be the same. You can't have 50 and 50 and 90. That will not add up to 180. You cannot have 60 and 60 and 90. That will not add up to 180. It's an isosceles triangle because 18 and 18 have to match up. So that means these two have to match up. Okay, so this one in part B has to be 45 degrees. All right, now let's go to A. I'm going to play the what if game on this, and I'm going to use a pencil, so please use a pencil because we may be wrong, but we need to figure it out first. So let's say, what if this was 45 degrees, right? I'm going to put a question mark. If this was 45 degrees, this would be 90, and then back from what I said about part B, that would have to be 45 degrees also, because 45 plus 90 plus 45 is going to equal 180. But if these two are the same, that means these two here, the legs, must be also the same, and that's not true. So x is not 45. Okay, so we can throw that out. So it leaves us with the option of it has to be more than 45 or it has to be less than 45. Because we know equal to 45 is not going to work because it has to be an isosceles triangle. So let's say it's, I don't know, I'm just going to pick one. Let's see if it works out. Let's say that it is less, or I guess we can go with the more than or the less than. Let's say it's less than, I suppose. Let's say it was 30 degrees, right? Let's say less than 45. Let's say it's 30 degrees. Okay, well, if that's 30 degrees, then this one over here must be, what is 90 minus 30? Oh, 60, right? So let's 60. Okay, so let's see. Biggest side, which is the hypotenuse, is across from the biggest angle. That works out. Smallest side, which is the 3, is across from the smallest angle. Okay, that works too. And then biggest side, 4, then 4, which is in the middle, is going to be across from your middle angle. Okay, so that works. So x is good to go, right? It might be 30 degrees because it might be less than 45. So let's see if it would have worked the other way around. Let's say x was more than 45 degrees. Let's say x was the 60 part, right? Well, that would mean this part would be the 30, because 30 plus 60 plus 90 is going to give you your 180. But it fails the biggest, or it fails the smallest side has to be across from the smallest angle, because the smallest side is 3, but it's not across from the smallest angle. It's across from the medium angle. And 4, which happens to be the medium side, is across from the smallest angle. So it's definitely not more than 45. It can't be equal to, so it has to be less than 45 degrees. All right? We don't know what it is, but all we know it's 45. And the same thing goes with C. So let's say x was 30 degrees, right? Okay. That would mean this have to be 60 degrees up here. And now we see we have a problem. 2 being the smallest side, technically, is not across from the smallest angle. 8 is across from the smallest angle, but 8 is not the smallest side. So x can't be 30, right? So it must be maybe 60 then. So let's see. That's a question mark. We have, or actually maybe, I don't know, it doesn't really matter what we do. We could try 50, right? And then this could be 40. I'm just making numbers up. My point is to actually get you to understand I'm picking a number just to guess and check based on the fact that it's over 45 degrees. So let's say x is 50 and this is 40. Okay, well 40 is the smallest angle. It's across from the smallest side. 8 is the medium side. It's across from the medium angle, so this works out. So I don't know what x is. It doesn't really matter. All I know is that it has to be more than 45. Okay? It can't be equal to 45 for the same reason that I said back in B. It has to be, if it was 45 and 45, it'd have to be 45, 45 for both, and these two sides would have to be the same because it'd have to be an isosceles triangle. Okay, so that was up to 88. If you have any questions, please let me know.